Hello students, my name is Dr. Ashutosh and in today's lecture we are going to discuss about levers. So before starting with the lever, let's understand a very familiar concept which is force. We all have studied about force in the past, but before starting and knowing about the lever, let's discuss it once again. A force is a push or pull. A force can be experienced in the form of a push or a pull which is exerted by one object or a substance on another object. We already know what is a force. It is a push or a pull which is exerted by one object on another object. And the SI unit of a force is Newton, which we usually denote by N. So whenever we talk about forces inside our body, we always classify the forces into two types. The force can either be external or it can be internal. So whenever I talk about external force, it is a force which pushes or pulls on the body and it arises from the source outside the body. So remember, external force, the source of that force lies outside the body. And whenever we talk about internal force, so these are the forces, these are the push or pull which arises from inside the body by their structure. So to understand this, assume an example that you are standing and your friend pushes you from back. So the push that your friend gives to you is an external force, and the resistance that you get from the body, you try to maintain the position, you do not fall at that time, you try to maintain the upright position, so your muscles contract to prevent you from falling from this external force. So the forces that is generated by your muscle is an internal type of force. So I assume that this is clear. Let's understand this by one more example. So as you can see in this figure, this is the figure of a head which is stabilized by the neck extensor muscles. So in this example, the gravity and the load of the head are the external forces. These are the forces which are arising outside the body, and the muscles are contracting. The cervical extensor muscles are contracting to prevent the flexion of the head or falling down of the head. So the force that is produced by the muscle is an internal type of force, while the gravity and the resistance force are external type of force. So I hope it is clear with you what is an external force and what is an internal force. Now moving on to the main concept of this lecture, which is a lever. So lever is a simple machine which consists of a rod. So remember, whenever we will talk about the lever, there has to be a rod which is suspended across a pivot point. And usually in physiotherapy, whenever we understand biomechanics, that pivot point, we give the term of fulcrum to that pivot point. So in a lever, there is a rod and there is a fixed point across which our load is suspended. So important function of a lever is to convert the force into torque. So students, please remember this, that one of the most important function of a lever is to convert the force into torque. So there is a difference between force and torque. So the difference is that whenever we talk about the angular motion, in that motion the force is acting upon any object at an angle. So whenever a force is acting upon any object on an angle, we usually describe that force by using the term torque. So remember, the difference between the force and torque is that a torque is used to describe the force in an angular motion where the force is acting at a certain angle, So internal and external forces produce torque throughout the body through a system of bony levers. So remember, I told you that there is a rigid rod in a lever. So in our body, that rigid rod is always bone. So this all lever system is around the bones, and bone functions as the rod. So there will be a fixed point, which is, we call that point a pivot point or fulcrum. So next point is that important forces which are involved. These are the forces by the muscles. So muscles give forces, they contract and produce the forces. Force is always applied by the gravity. Gravity pulls the body down and we try to maintain the erect posture by using the anti-gravity muscles. and physical contact with the environment. Assume you are walking or running. So there is always a physical contact with the environment. For example, if you are walking, there is a ground reaction force which is coming into play. So these are some important force that we will study in the biomechanics and whenever we will describe the lever. So you can see there is an example of a lever in which fulcrum is the axis and force is produced by the extensor muscles and resistance is given by the ball. In this example we can see the skull. So the resistance in this case is the weight of the head and the gravity that is acting on that head. So we classify the lever into three types. They are first order lever, second order lever and third order lever. So let's start first with the first order lever. So this is a type of lever which has the fulcrum in between the weight and the force. Remember, in first order lever, fulcrum is in between the weight and the force. As you can see in this example, the example that we studied earlier, maintenance of the upright posture of a head in sagittal plane. So whenever we will ask what is the lever, first order lever, give that example. So you should remember that posture control of the head in sagittal plane is a classic example of first order lever. Let's understand how it is. So as you can see in this image, there is a fulcrum. The fulcrum is at atlanto-occipital joint. And the effort is put in by the muscles of the neck, cervical extensor muscles, and the load is produced, as we already discussed, by the skull and the gravity. There is one more important concept that you must know, which is of moment arm. So this is a very basic concept, that moment arm, it is a perpendicular distance from the fulcrum to the point of force. It can be to the effort also, it can be to the load also. So in this example, there are two moment arms. EMA, this is external moment arm, and IMA, this is internal moment arm. So the perpendicular distance from the fulcrum to the external load is always external moment arm. And the perpendicular distance from the fulcrum to the effort in this case is the muscle force. So that distance is internal moment arm. These are two very important concepts that we must understand in order to get a very much important insight about lever. So you must be, till now you must have been very much clear with what is a lever. There are three types of lever. We are discussing first order lever right now. In this first order lever, fulcrum is in between. And we also know that moment arm, it is a perpendicular distance from the fulcrum to the point of force application. And moment arm can be internal and it can also be external moment arm. Internal moment arm is the fixed point. It is a perpendicular distance from the fixed point to the effort, from the point of effort, right? And external moment arm, it is the perpendicular distance from the fulcrum to the load. Now let's move on further. So this is a data. So right now, as you can see, that head is in an upright position. So the torque that the load that is applied is actually managed by the effort. So there is an equilibrium state right now. So we can assume that the torque 1 is equal to the torque 2. The torque that is produced by the load and the torque that is produced by the muscle are actually equal right now. And we also know that formula of a torque is force into MF, here is muscle force, into moment arm, right? So muscle force into internal moment arm is equals to head weight, which is a force by the load, into external moment arm, because the head is in equilibrium position. It is not moving down or it is not moving up, right? So we have to find out the muscle force. What is the amount of muscle force? If we know the weight of the head, yes, we know that it is 10.5 lbs in this example. And internal moment arm, yes, that also we know. We know the distance of the muscle's insertion from where the muscle acts to the fixed point, it is 4 cm. And external moment arm also we know that it is 3.2 cm. Then by using this calculation, we can find out the muscle force that is produced by the muscle, right? And in this case, if you will see, it comes out to be 37.4 Newton or 8.4 lbs if we go with the US system. Okay, so because both the torques are equal, it is in equilibrium state, so we can say we can use this calculation and find out the muscle force. Now there is one also very important concept that you must know. It is a mechanical advantage. As I told you earlier about the moment arm, internal moment arm and external moment arm. So mechanical advantage is a advantage whenever you will put less force but less effort, but you are getting a more output. So output force, if it is more than the input force, the force that you are putting in through the lever, it is less than the force you are getting. So if you are giving only 10 Newton of force but the force that is produced is 20 Newton, that means you have a mechanical advantage of 2 Newtons. So there are two formulas, basically two formulas are there for mechanical advantage, which is output force divided by input force. It means the force that you are getting divided by the input force, or it can also be found out by dividing the internal moment arm upon external moment arm. As you can see here, internal moment arm is 4 and external moment arm is 3. So mechanical advantage automatically comes out to be 1.24, because if you divide 4 by 3.2, it is 1.25. Right? Now moving on, as you can see in this example also, the lady is pulling the lever arm downwards and the load is lifted. So the lady is putting less effort and the load gets lifted up because the distance from the pivot to the effort, which is a moment arm, in the case of body we'll say it is an internal moment arm, is more than the external moment arm. As you will shift the pivot point to the left side, the moment arm will get, internal moment arm will decrease, and the lady has to put more effort in order to lift the load. Okay, I assume that I have cleared all the concept of first order lever. Now you should know, before moving on, there is an important thing that you also must be aware of, that which is that first class lever may have a moment arm less than 1, because fulcrum is in between. It can shift to the left side also, to the right side also. So you can have less than 1 moment arm in the case where the external moment arm is more. It can be equal also if you have internal moment arm and external moment arm same. Then it will be a equilibrium lever, and it can also be more than 1, because if your internal moment arm is more, if it is shifted to the external load, then you will have the mechanical advantage, and it can be more than 1 also. So you have to remember this. Now moving on to the second order lever. So in this type of lever, the weight is in between. The load is in between the fulcrum and the effort. And the classical example of this second order lever is standing on toes. So whenever you stand on toe, you do plantar flexion movement of your ankle joint. And which are the muscles that are causing this movement? They are gastrocnemius, or I will say more overly calf muscles are causing this. Okay. So as you can see in this example, that fixed point, this is the fixed point, and it passes through the MTP joint, metatarsophalangeal joint, and your body weight is falling over here, this point, right? And the distance of this, perpendicular distance of this point and the fulcrum is external moment arm, and your muscle is inserting here at calcaneal tuberosity. So the distance from the calcaneal tuberosity to the fixed point is internal moment arm. So as you can see in this picture also, that internal moment arm is more than the external moment arm. So in this type of force, the muscle has to give a less effort to lift the load, right? Because here it is a mechanical advantage, as internal moment arm is more. Same as we found out the data of muscle force in the first order lever or first class lever, we can also find out in the second class lever. Assume that we do not know what is the muscle force produced by the calf muscles, but we know that what is a body weight. So assume the body weight is 150 lbs, 150 pounds, and internal moment arm is 12 centimeter. It is the point of insertion, perpendicular distance from the point of insertion of the calf muscle to the fulcrum. And external moment arm, it is the distance between the point where the body weight is lying and the fulcrum, the distance between these 2 points, and it is 3 centimeters. So here you have a tremendous amount of mechanical advantage of 4. So in this case, you will put lesser effort to lift the body, right? But a lot of times students ask me that in this second order lever, whenever we do standing on toes, we get a lot of pain in the calf. So this is a very commonly misunderstood topic, that students assume that muscle is producing less force, so we should not feel tired when we are lifting on our metatarsophalangeal joint. But it is not the case. Why? Because muscle is anyways contracting. The muscle is contracting less, but that less force is enough to make you fatigue. So remember this thing, that muscle is contracting over here. It is just contracting less than its capacity. So second order lever always has the moment arm more than 1. So this is why we call the second order lever the lever of mechanical advantage. This is a very important point to be noted, that this is the lever of mechanical advantage. Now moving on to the third order lever. So this is the type of lever which has the effort or force in between the weight and the fulcrum applied. So there is a fulcrum and there is a load. In between the fulcrum and load there is an effort. Classic example of third order lever is flexion of elbow. As you can see in this example as well, fulcrum is at the elbow joint, and the effort, if you are doing a flexion of elbow, then your biceps is contracting and they are producing the flexion movement. So its point of insertion lies in between the load, and the load here in this case is the dumbbell. So the direction of movement is upward and effort is situated between the fulcrum and load, so that external moment arm, as you can see, the external moment arm is the distance between the fulcrum and the load. It is more than the internal moment arm, which is fulcrum and the effort. So it is the lever of mechanical disadvantage. This is the internal moment arm and this is the external moment arm, the distance between the load and the fixed point. Internal moment arm is the distance between the muscle's line of insertion, perpendicular distance, and the fixed point. This is internal moment arm. So again, this is the same calculation that we can make, and here you can see that mechanical advantage is only 0.13, which is really very less. Now third order lever always has the moment arm less than 1. This is why they are called as the lever of mechanical disadvantage. But they are lever of mechanical disadvantage, but they have the capability to produce a high speed movement. They are also called as lever of speed. And in our body, majority of the lever, if you ask which type of lever is commonly present in our body, it is a lever of speed, third order lever. Now because they have the ability to produce a speedy movement, they are present in the body. Majority of the places, whenever we will talk about the muscle forces and the lever system, they are the third order lever which are present everywhere. So why they are called as a lever of speed? So this is a very important concept, that why third order lever is called as the lever of speed. As all points throughout the lever share the same angular displacement and velocity. So assume that there is a rod. So it is fixed at the same point. So assume that this is a rod and it is there at a fixed point. So if it is moving down, assume this is a point A, this is a point B, this is a point C. They are moving down, they move just 10 degrees per second. They moved at a velocity of 10 degrees per second. So after a second, they move 10 degrees. So point A also moved 10 degrees, point B also, and point C also. So they have same angular velocity and displacement. Remember this. But the interesting fact over here is that more distal the point on the arm, so more the distal the point on the arm, move with the greater displacement and velocity, because this point A has to cover a greater distance to come at 10 degrees, and B has to cover a less distance, and C has to cover even lesser distance. So A will have the highest speed and B will have the lesser speed than A, and C will have the least speed. So more the force that will be produced, more the velocity that you can generate. Example, let's take an example. You are playing lawn tennis and you have to hit the ball into the other player's court, and you have to react very suddenly. So in that case, the third order lever comes into play. The more distal, because the racket is at the distal part of your hand and you are moving it with the third order lever, so you are producing a larger force and you are producing even the greater velocity of the distal segment, and you are able to react very quickly and deliver the ball into the other one's court. So this is the prime example of the third order lever, and that is why they are present in numerous amount in our body. So I hope I have cleared all the three type of levers. What are they? What is a lever? What is a first order lever? Their significance in our body, their example. Second order lever, their significance and importance. The concept of mechanical advantage should be clear with you guys, and also the third order lever and why they are called as the lever of speed. Now there is a question for all you guys, which is the question is, which is the type of lever that has the fulcrum in between the weight and effort? You can reply to this question. You can give the answer in the comment box. Now this is a second question for you guys. Here you have to find out, there are 4 points in every image, and in these image you have to find out which is fulcrum, which is weight, and which is effort. Okay, and these all you have to answer in the comment section. That's it. Thank you so much for listening so patiently.